This instrument that I'm standing next to is one that we built in my lab. What we've done is we've mounted this commercial surveillance camera to the tower, and this camera can point and look at different portions of the canopy. And the whole goal of this project is to make these measurements of how light is used by the plant and relate them to what the flux towers are seeing.
So up at the top of the tower, you saw the Cameron system, which has a camera, which produces images like these. This one is of our most recent image of the sky. So we're interested in looking at this solar-induced fluorescence signal, which basically originates from the fact that plants have developed a couple of different ways to get rid of extra energy that they can't use right away. One of those ways is to sort of just throw it back away as heat, and the other is to emit it as a small amount of fluorescent light, which is what we're looking at here. So SIF can help us answer a couple of different and really important questions. So one of those is learning a little bit more about the productivity of all of these plants, or when we scale SIF up to, say, measurements from a satellite, we call that GPP, or gross primary productivity. So at that scale, SIF is really well correlated with GPP and can help us monitor the productivity of plants all over the world really quickly.
So measuring GPP is very difficult, and what we've done with this system is we have SIF, but we have a number of other parameters that we're simultaneously measuring. And by doing this in the fetch of the NEON and the EMS tower, we can directly couple these measurements to those long-running measurements. And since we've installed this instrument, the NASA satellite that's measuring the same property from space has started to target Harvard Forest. Since LTER1, land use has been a central theme of the Harvard Forest LTER. And in recent years, my group has gotten pretty focused on thinking about land use and the impacts of land use after the changes have happened. As we look across the landscape here, and we could see for quite a distance, there are no edges. But even in a rural location like Petersham, about 15% of the landscape has edges. Those are edges that are next to agriculture, next to roads, next to houses. What we've been finding in the last years is forests that are next to edges operate a bit differently. And it makes complete sense if you think about it. A forest that's influenced by an edge will have a different light environment because you'll have lateral light coming in. It'll have a different moisture environment because you have lateral light coming in. All of these factors will influence the dynamics of the system and the potential for it to take up carbon. That is pretty exciting because it means that we have an unaccounted for carbon sink. So across a 20-state area that we've done this analysis, it's a 6% increase across the whole the 20-state region. In some places, like more developed states like Massachusetts, it's a 20% increase in the amount of carbon stored and taken up. Maybe there's a higher value in conserving some of these small fragments than we had previously considered.